Unit 1, Lesson 7, Modeling Linear Systems of Equations. Let's recall solutions. We've talked about solving for solutions, and we have three different ways to solve. Using a graph, we could use the method of substitution or elimination. We also remember that when we're talking about a linear equation, we have y is equal to mx plus b. M and b are things that we know about our line. B represents the y-intercept, and the y-intercept is fixed. So this would be our fixed value. For M, we have the slope, or we could say this is the rate. Now, we have an x, and we have our y. The x is what's being multiplied to the rate, and this is going to be variable. It depends on how many units we're looking for. Now, when we have a variable, you always have to define the variable. And when we're defining it, the hint is always take a look at the rate, and the unit that it is out of is usually what we have as our variable. Look at the rate, and we're going to use the unit that's after the slash or the word per. So, for example, if I have a rate of $10 per hour, then my variable will be the number of hours. Y is the total amount. So, the total will depend on what you're calculating. For the next couple of examples, I want us to write the equation, but not solve them. Because we know how to solve, it's just setting up the equations that are going to be the tricky part for today's lesson. Right now, we have Catherine has two job offers. Company 1 is offering a fixed salary of $800 a month and 5% commission on the monthly sales. Company B is offering a fixed salary of $500 per month and 8% commission on the monthly sales. For what amount of sales would the monthly income be the same for each equation? We're asked to look for the monthly income. So the fact that it says $800 per month or $500 per month is not the rate, because it's just telling us that this is going to be the base salary for the month. On the other hand, commission is the rate, because commission is a percentage of the sales that you make, and you're going to be getting that back added on top of your salary. So let's take a look at this. We have company A. We know that the fixed amount is $800. So B is equal to 800. The rate is 5%. But 5% is a spoken term. If I'm using 5% in math, I need to make this a number that's divided by 100. So 5% is equal to 0.05. Now, my equation based on this piece of information, we have y is equal to 0.05x plus 800. Next, we have company B. We know that the fixed rate is $500 a month, and there's 8% commission. So, as a number to use in math, we need to use 0.08. So, as an equation, company B could be modeled by y is equal to 0.08x plus 500. Now we have our two equations, and for us to find where the monthly sales would be equal to, I would solve this using substitution. Example 2. Write the equation for the relation. Don't solve. The sum of two numbers is 125. 5 times one number minus 3 times the other number is 41. Find the numbers. Now, there's a lot of information that's going on here. Let's take each one of these sentences and simplify them. So, the sum of two numbers is 125. Now, every time you see the word is, you know that that is represented by an equal sign. So we know that something has to be equal to 125. The word sum means I need to add. What am I adding together? Well, I'm adding together two numbers. So I know that if I have the first number plus the second number, this will equal to 125. Now let's identify our variables now. We could say let x be the first number and let y be the second number. So with this let statement, my equation would now be x plus y is equal to 125. This is our first equation. Right, the second part, we have this information. 5 times one number minus 3 times the other number is 41. Now let's interpret that. We know that at the end it has to equal 41. Well, it has 5 times one number. So my first number is an x. Let me say that 5 times one number will be 5x. Next is minus. The word minus means we're going to subtract. And we're subtracting 3 times the other number. So 3 times the other number is represented by 3y. We have our two equations now. And we can use substitution or elimination to solve. Right, example 3. Nathan is 8 years older than his sister Stephanie. In 3 years, he will be twice as old as Stephanie is now. How old are they now? Well, we have a couple things going. We know we're looking for how old they are now. So that means I need to know Nathan's age and I need to know Stephanie's age. Let's write a let statement based on that. Let n be Nathan's age. Let X be Stephanie's age? Just a side note, I am a little leery about using the letter S as a variable because often the S looks a lot like the 5 and sometimes it gets mixed up in writing. Okay. So the first part of the sentence tells us that Nathan is 8 years older than his sister Stephanie. Well, we know that the word is means equals. So I'm going to put an equal sign here. And Nathan is represented by the letter N. Second part of the statement, 8 years older than his sister Stephanie. So that means when we have 8 years older, we're taking Stephanie's age and we're going to add 8 years. And that would equal Nathan's age. So we have X plus 8. That's our first equation. Okay, the second part is in 3 years, he is as old as Stephanie is now. Now, as a side note, we know that Stephanie and Nathan are represented by N and X right now. But if we were going to say their ages in 3 years, Nathan will be 3 years older. So Nathan's age will be N plus 3. Okay, let's break this part up. Now, the verb to be gives us is in present tense or will be in future tense. So we know will be is representing my equal sign. And 3 years, in 3 years, Nathan is going to be N plus 3. Twice as old as Stephanie is now. I'm going to take Stephanie's age right now and multiply it by 2. We have our two equations. And really, the hardest part of these word problems is taking the words and translating it into math. Okay, next example. A vending machine contains $27.70, all in quarters and dimes. There's 199 coins in all. How many types? How many of each type are there? So we know that the two things that we're dealing with are quarters and dimes. Let's write our let statement for that. Let Q be the total number of quarters. Now, I want to be very specific that this is the number of quarters because we could be talking about value, but I don't want to talk about value. I want to make sure that we're discussing Q as the number of quarters. The second one, we can say let D be the number of dimes. So the first equation that we're going to make is an equation that talks about 199 coins. This is talking about the value of coins, not the value, sorry, the total number of coins. So because this is the total number of coins, I'm going to add the two of them together, Q plus D, and that's going to equal to 199. Another part of the equation, or another part that is informative, is the 2770. Now, this 2770 is talking about the value. So, just as a side note, when we're talking about value, we need to multiply the value with the total amount to get the total um, amount of dollars. So, side note, if I had 3 quarters and 5 dimes, how many, what's the value? So, how you would do this, in your head, you would probably say, I'm going to take 25 cents and multiply it by 3. Then I'm going to add 5 times zero point 0.1, which is the value of a dime. So that equals 0.75 plus 50 cents. And in total, we have $1.25. But what you did here was we had to take the value of the coin times the number of coins to give us the total value. So value of coin times the number of coins. So in this case, let's come back to this. We know that the value of a quarter is 25 cents. So I'm going to have 0.25q plus the number of dimes and the value. And this is equal to 2770. We have a value equation and we have the total number of coin equation. With these two equations, we can use substitution or elimination or graphing, and we'll solve. Jerry invested $10,000 for 1 year. Part of it was invested at 8% per year, and the other part was invested at 10% per year. The total interest for 1 year was $940. How much was invested at each rate? Now, remember the saying, don't put all your eggs in one basket. Well, this is what it often means. People will invest money, but they don't invest it all in one place. So Jerry wanted to invest $10,000, but instead of putting all $10,000 into one investment, Jerry put a part of the money in an investment that gave 8% per year, and another part of that money was invested into something that gave 10% per year. Now, we don't know what part of the 10,000 was invested. So we're just going to have to separate that and identify that as our X and Y. So let X be a part of the $10,000. Let Y be the other part of the $10,000. This first sentence is talking about the total value. So we know that X and Y together will give us a total of 10,000. That's our first equation. The second part is interest. We know that total interest was equal to $940. Now, just a side note to remind you, interest is created by the sum of money times your percent or your rate. So, our rate for the first amount is 8%. We have 0.08 times x, which is the first part. The second part of money was invested at 10%. So 0.10 times y, and that gave us a total interest of $940. We've created two equations. One was the total amount, and the other one was for interest. Now we have enough information to solve for the x and the y. Slides 8, 9, and 10 are questions for you to try on your own. Pause the video and go through this. Right, solutions for the questions to try on your own. Slide 8. This is slide 9 and slide 10. Right, the last example we have here, we don't need to solve, just setting it up. This is an example that will stretch you a little bit more, but we'll talk more about it in the next lecture. A grocer creates 70 pounds of a bean mixture that sells for 41 cents per pound. It's made with red beans that are worth 35 cents per pound and fava beans that are worth 45 cents per pound. How many how many pounds of each type did he use? Now we know that there are two types of beans, and that's what we're interested in finding out. So let's create our let statement. Let x be the weight of red beans. Let y be the weight of fava beans. We've got our let statement, so let's create the two equations. Okay, so the first piece of information that's useful to me is 70 pounds of a bean mixture. This is giving me the total weight. So I know that x and y together will give me a total of 70. So x plus y is equal to 70. And the second part is a little bit trickier. We're now talking about the value of the beans. Oops. So we know that the first amount is 35 cents. We know that the fava beans are 45 cents, and the mixture is 41 cents. Now we know that the whole mixture is 70 pounds. So we can take that and make it into a value. So there's 70 pounds in the entire mixture. So 0.41 times 70, and that gives us 28.70. That's the total value of the beans. With the red beans and the fava beans, we don't know what the weight is. So we're going to have to take our X and our Y and create a statement like this. So red beans, we have 0.35 times the weight, which is X. Fava beans, we have 0.45 times Y. So as our equation, we would have 0.35x plus 0.45y, and this is equal to 2870. We have our two equations, one for the value and one for the total weight, and now we're able to solve it.